Hello. This is the first of two videos on non-steady state diffusion. The equation that we use to solve non-steady state diffusion problems is presented here on the top. C sub x minus C0 is C sub s minus C divided by C sub s minus C0 equals 1 minus the error function of the quantity x over 2 square root dt. In the last module for lecture 6, I introduced the error function, and I'll be using the table that I handed out in class to calculate or to determine the error function of different values for x over 2 square root dt. The terms are defined here. C sub x is a concentration at depth x. C sub x units are weight percent carbon. X units are in meters. C0 is the base concentration of the steel. C sub s is the concentration at the surface. D is the diffusivity at whatever the temperature given. And T is the time in seconds. So we're going to talk about two different problem types. The first is where the unknown is on the left side of the equation. So I'm given x, I'm given time t, I'm given temperature or so that I can calculate d, or I'm given d, and I need to calculate one of these three unknowns, cx, c0, or c sub s. The second problem type is where the unknown is on the right side of the equation. I'm given all these concentrations, and I am trying to calculate x or time t, typically not the diffusivity. So for this video, I'm going to look at problem type 1. For all of the carburization problems that we work, d sub 0 is 2.3 times 10 to the negative 5, and Q is 148 kilojoules per mole, which is 148,000 joules per mole. So here's an example. I'm given that I'm doing carburization on a 1010 steel, so that means C0 is 0.108% carbon for 10 hours. So T in seconds would be 36,000 seconds. At 1,000 degrees C, which is 1273 K. And I'm going to have to calculate D given that temperature. Also, the surface concentration, C sub S, is 2.2. So writing out my equation, if I say on the left I've got C sub x, which is my unknown, minus 0.1, which is the C0, divided by C sub s, 2.2, minus C sub 0, 0.1, is equal to 1 minus the error function. And when I get to the end of my problem description, I see that depth is 2 millimeters, so x is 0.002, 2 times the square root of d times time t. And I'm going to have to calculate d. All right, so let's set this up then. First, I'm going to need to know d. So d at 1273 Kelvin is equal to d0, 5 times 10 to the negative 5. E to the minus Q was 148,000 divided by R, 8.31 times T 1273. I don't need that line. Okay. So again, C sub x is my unknown. Cx minus C0, 0.1 over C sub s, 2.2 minus 0.1 is equal to 1 minus the error function of the quantity x, which is 0.002, over 2 times the square root of, oh, I set this up and I didn't calculate it. Here's my equation to find d. That ends up being equal to 1.93 times 10 to the negative 11. And that will go here. That is the value for d. And time was 10 hours, 36,000 seconds. So my unknown's on the left side, just like I defined for problem type 1. And everything in the parentheses here, I know the value of. So this whole quantity, the inside here is a value of 1.2. And so if I use my error function table, if z, that's what's inside this parentheses, is 1.2, then error function z is 0.9103. So this value would be 0.9103. Okay, I got a blank page to work with here, so I'll continue. What I have now is C sub x minus 0.1 over 2.2 minus 0.1 is equal to 1 minus 0.9103, which is 0.0897. So I take this denominator and multiply it by 0.0897, and I have that C sub x minus 0.1 is equal to, let's see, 2.1 times 0.0897. And so you solve that, and we get a C sub x value of 0.298% carbon. So that's a problem as given. My answer is that the surface concentration 2 millimeters below the surface is 0.29 weight% carbon. Remember, the base concentration was only 0.1, so we've increased the concentration of carbon substantially. All right, what if I have a follow-up question? What if the follow-up question says, okay, instead of doing this on 1010 steel, what would happen if we used 1020 steel? So I'm changing C0, and everything else remains the same. So instead of 0.1, I'll have C sub x minus 0.2 over 2.2 minus 0.2 is 1 minus the error function of everything the same as I just had. I didn't change x. I didn't change temperature or d. I didn't change time. So z, that value inside the parentheses, is the same as it was. And error function of z is the same as it was. And 1 minus the error function z is the same as it was. So what we had before, error function z was, let's see, this was 0.9103, just like before. And so this is 0.0897, just like before. I don't need to use that error function table. And so c sub x is equal to 2.0 times 0.0897 plus 0.2. And that should give you a carbon concentration at depth x of 0.38. So if I increase the beginning concentration from 0.1 to 0.2, I'll at the same time increase C sub x from 0.29 to 0.38 weight% carbon. And I don't need to use the error function table because I changed a value on the same side of the equation as my original unknown. I changed that value. The other follow-up question doesn't give me that shortcut. So here it says, okay, let's look at this process that I talked about in step 1, and I changed the duration from 3,600 or 36,000 seconds, double it, to being 72,000. So T is changed from 36,000 seconds to 72,000. And so now I'm changing a value that is inside the parentheses on the other side of the equation from my unknown. So I really have to start from scratch. I have C sub x minus, and we're going back to using the original carbon concentration of 0.1 divided by 2.2 minus 0.1 is equal to the error function. Sorry, no. Jumping the gun there. It's equal to 1 minus the error function. X is unchanged. Temperature and D are unchanged. But my time, instead of being 36,000, is now 72,000. So this value in the parentheses is no longer 1.2. This value is 0.8483. And so if I look at my error function table, under the column Z, for 0.8483, I have a value here of Z of 0.85, which is very close. So the value error function of 0.002 divided by 2 square root 1.93 times 10 to the negative 11 times 72,000 is equal to 0.77 This value right there. Okay, so I'm going to move to the next open slide here. And I have c sub x minus 0.1 over 2.2 minus 0.1 is equal to 1 minus 0.7707, which is 0.2293. So c sub x minus 0.1 would be equal to 2.1 times 0.2293. And if I move this 0.1 to the other side of the equation, I can add those two, and c sub x in this case is equal to 0.58 weight percent carbon. So if I double the time, I double the concentration. I went from 0.29 weight percent carbon to 0.58 weight percent carbon. All right. So that's it for this first type of the non-steady state equation. I'll make another video for the type where the unknown is on the right side of the equation.